Hello everyone and welcome back to Physics Rich, your one-stop channel for the preparation of IIT-JEE Mains Advanced NEET and also AP. Guys, we are doing the Awesomeologist series in collisions and I am back with, well, the same problem that we have just discussed in the previous video, and in fact, we also found the answers to that. Isn't that surprising that I am back with the same problem once again? Yes, guys, I want to tell you a different approach to solving this problem. If you haven't watched the previous video, I highly recommend you go back and watch the previous video so you learn the standard method. I will recap the standard method very quickly and then we will move on to the next best method to solve this problem. So guys, to recap, let me just remind you what this problem was. This is a mass with a velocity v naught and it is traveling on a frictionless table. While these two are also identical masses, they are connected with a rod that is massless, and this assembly is kept on a frictionless table. This mass hits this mass elastically, and after some time we have to find the velocity of this mass and also the angular velocity of the system and the impulse on this mass c, and also the velocity of center of mass of this assembly. Now, we have already found the answers, and the typical method of solution is using conservation of angular momentum for the entire system, and then using conservation of linear momentum, and also conservation of mechanical energy. But guys, I mean, we have solved this, but I would like to introduce to you another approach, a very intelligent and a very awesome approach, because that's how it is, Awesomeologist. So you see guys that I have drawn the same system once again, and I have given this mass m, which is body a velocity v naught, and it is going to come and hit over here. So you know what I'm going to do now? I'm going to try to apply Newton's law of restitution or the restitution equation. But for that, what I need is that I need to understand that this mass A and this mass B are colliding with each other, all right? And on mass A, there will be a certain impulse. On mass B, there will be a certain impulse. Also, I understand that mass A will be moving along this direction only because that's where its velocity is. However, with respect to mass B, we cannot see the exact same thing. Do you know why? Because you see, it is rigidly connected to the mass C. Now, because it is rigidly connected to the mass C, this mass will only move along this rod. And why is that? It's because the rod is going to give it a certain impulse in this direction. Correct? And because this mass will be getting an impulse along this direction, this mass B will also get an impulse in this direction. But you see guys, we can understand with the help of basic rigid body kinematics that if B and C are connected to each other, then their velocities along their line joining must be the same, which is why B, the object B, must be having the same velocity as object C along this rod. Okay, and we know that we have given it a value of V dash. However, very important thing is that in rigid bodies, we have learned that every object, every particle, every point rotates about every other point with the same omega. So if I sit in the frame of reference of C, then I will observe that B will be rotating with an angular velocity of omega, such that its velocity with respect to C will be L omega, where L is the distance of this length of this rod. All right. So if you look at the velocity of B from the ground frame, you can see that velocity of B with respect to C, okay, velocity of B with respect to C will be simply VB minus VC. All right. And that is this L omega. Okay. Let me just write this as a VR. Okay. Because this is VR. VR stands for like rotation. So I can say that velocity of particle B is actually the vector sum of VC and VR. All right. So what is VC? VC is just simply V dash. And that's why the velocity of B will be the vector sum of V dash and VR. Now you see guys, I can conserve, what can I conserve? I can conserve linear momentum in two ways. Okay, so let me show you how linear momentum conservation will work in this situation. So let's conserve linear momentum. But this time we will conserve it slightly differently. How will we do it this time? See, I'm assuming that this is the x-axis and I'm also assuming that this is the y-axis. And I will write that momentum along the y-axis is 0. Why is it? Why is it 0? It's 0 because of obvious reasons. And that is, there was no initial momentum along the y-axis. So I will just simply write the momentum of C, which is mv dash, and I know that this angle in the question was given to be 45 degrees. Now mv dash cos 45. Okay, so there is 45 degrees here also, and there is mv dash cos 45. There are two of these. Okay. Now this one is going down, and because the rod and VR will be perpendicular to each other, so you can simply say that you can minus VR again, because this is 45, right? So we can just simply write cos 45 once again. It doesn't really matter. Cos 45, sin 45, they're all the same. So any which way, this is getting cancelled, and there is supposed to be a mass m over here, which is also getting cancelled. So I get 2v dash equals to VR. A very nice, very important equation. 2v dash equals VR. Very important, very nice, very simple. Okay. So now let's calculate what happens if we conserve the momentum along the x-axis. So sigma px initial and sigma px final are the same. So what is the initial linear momentum along the x-axis? So let me write that with the green color. So I will write m v naught. Okay, this is the initial linear momentum along the x-axis. That should be equal to m v1. Now what is v1? Guys, v1 is the velocity of this guy after collision, plus now this guy, both of these. Okay, m v dash cos 45. Again, we can use cos, sine, whatever, it doesn't matter, it's 45 degrees. And what about this guy? This guy will have m v dash cos 45 because of this velocity, and also m vr cos 45 because of this velocity. Okay, so let's consolidate this whole thing. I can see that all the m's are getting cancelled. I don't need to write all these m's, they are all going to get cancelled. What, however, I can write is v naught equals to v1 plus, what is this, 2v dash cos 45, 2v dash cos 45 plus vr cos 45. Okay, now you see we have a v dash and vr. Okay, we have a v dash and vr equation in v dash and vr, which is going to be very helpful. But the problem is that now we also have v1. Okay, so this is our second equation. Okay, this is our second equation, but the problem is that we also have a v1. So how do we resolve this issue? How do we get rid of this problem? So guys, the best way of getting rid of this problem is to, let me just remove this very quickly. The best way is to apply Newton's law of restitution. Now you see guys, this Newton's law of restitution is only applicable along the line joining A and B. See, in order to apply Newton's law of restitution, which is, I mean, what is exactly Newton's law of restitution? It is the same thing that E equals to V2 minus V1 upon U1 minus U2. You must have studied this, or I like to write it as V1 plus EU1 equals to V2 plus EU2. Irrespective of how you write it, it's the same thing. This is what Newton's law of restitution is, and you have to apply it along the line joining A and B, because that's the line of impulse. Okay, A hits B and A applies impulse on B, B applies impulse on A, and along that line you have to apply the Newton's law of restitution. So how will we do it, guys? We'll start substituting values. By the way, one very important thing, E is given to be equal to 1 in this question because this is a perfectly elastic collision. All right. So let's write down, guys. So this is V1. V1 is basically the velocity of this guy after collision. So I will just simply write V1 as I have assumed in the other equations as well, plus V0. Okay, V1 plus V0 equals to U2 is well 0. This guy is not moving before the collision. I am only concerned with this V2, which is the final velocity of this guy along the x-axis, which is going to be simply V dash cos 45 plus VR cos 45. So what do I get? I get V1 plus V0 equals to, this is both 1 by root 2. So this is V dash plus VR upon root 2. So this is my third equation. This is my third equation. So guys, what all equations do I have? I think I have 3 linear equations now. So I have VR equals to 2V dash. That's my first equation. VR equals to 2V dash. And then I have this one, which is V0 equals to V1. V0 equals to V1 plus 2V dash cos 45. 2V dash cos 45 plus VR cos 45. And then I have this last equation, V1 plus V0. V1 plus V0 is equal to 1 upon root 2 times V dash plus VR. V dash plus VR upon root 2. Okay. Also, this cos 45, we can just, put that equal to 1 upon root 2. So I think there is no need to write cos 45 over here and over here. We can just simply take a root 2 over here, and you can take this VR over here. Now, these are just simply 3 equations, and we have 3 variables. The variables are V0, sorry, not V0, V1, V dash, and VR. So let's solve for it. I can see that VR equals to 2V dash is going to be making me very happy about it. So let's just put VR equals to 2V dash here also and here also. Okay, let's just put that. So what do I get? I get V0 equals to V1 plus 2V dash plus VR is again 2V dash, and divide that with root 2. So I get V0 equals to V1 plus 4 upon root 2 is 2 root 2 V dash. Okay, and then what about here? So this is my, let's call this equation A. Okay, and let's substitute over here also. I get V1 plus V0 equals to V dash. V dash is again, sorry, VR is again 2V dash. So it becomes 3V dash upon root 2. All right. So this is equation B. Solve equation A and B. What do we get? We can eliminate V1 quite simply. Yeah, we can put the value of V1 as 3V dash by root 2 minus V0. So let's put that. So from here we get V0 plus, now V1 is, it's V0 equals, V1 is 3V dash by root 2 minus V0 plus 2 root 2 V dash. Okay, everything seems fine until now. This V0 goes over here, it becomes 2V0. This is 3 by root 2 plus 2 root 2. 3 by root 2 plus 2 root 2. So what can we do about this? We can say that this is 3 V dash plus this root 2 goes over here, it becomes 4 V dash upon root 2. So I think we get V dash from here. This becomes 7V dash upon root 2, and from here V dash is 2 root 2 V0 upon 7. Is that the same answer that we got in the previous method for V dash? V dash is what? The velocity of C, right? Yes, we got 4m V naught upon 2 root 2, right? So I guess that is our answer. 4 upon root 2 is nothing but 2 root 2. Yeah, 4 upon root 2 is nothing but 2 root 2. So our answer is correct. Okay. So you see that this is a completely different method and it works just the same. Also, we can find VR as well from here. Very simply, you can get VR. Now VR is 2V dash. So 2V dash is simply 4 root 2 by 7 V naught. All right. And we can also find out V1 from here. So how will we find V1? We can find V1 from here. Equation A or B, it's the same. Maybe you can use any which way, any one you want. I'm going to use B. So let's use the equation B. So I get V1 plus V naught equals to 3 by root 2. And what is my V dash? V dash is 2 root 2 by 7. So 2 root 2 by 7 V naught. So this root 2 cancels and this becomes equals to 6 V naught by 7. Okay, and as you can see, I am approaching the answer yet again from here because I am going to get V1 equals to 6 by 7 V naught minus V naught, which is equals to minus V naught by 7. And this is exactly what V1 came out in the previous analysis, just the same. Okay, so you see that, guys, we can easily answer all these questions quite comfortably. We have found out the final velocity of the particle A as minus V naught by 7 again. We have found out the impulse on C because we found out the velocity of C. Multiply that with mass, you'll get the impulse. And angular velocity of the rod, guys. How do you find the angular velocity of the rod? Again, we have actually found that out because we have found out VR. You see, VR is L omega. Okay, this VR is L omega, and from here we get omega equals to 4 root 2 V naught by 7L. So you see, out of the 4, 3 of the answers are just handy. They are just handy. Now, how do we find out the velocity of the center of mass though? Let's check out how do we find the velocity of the center of mass. Now you see, guys, velocity of center of mass is actually a very interesting case. Now, if we were to, let me just remove all this portion over here. We have all the values. All we need is to find the velocity of the center of mass. So we have all this, okay. We have the value of V dash, we have the value of omega, we have VR, we have everything, okay. But now we are looking for finding the velocity of the center of mass. So how do we do that? How do we do that? So you can see that the velocity of the center of mass, first of all, it will be in this direction. Will the velocity of center of mass be anyway along this? No, not at all, not possible, because the overall impulse on this system is towards the right, which is why the center of mass should be moving towards the right. Now what you can do is that you can take the x component of this guy and this guy, C and B, and the velocities of C and B, and then you can use the formula m1 v1 plus m2 v2 upon m1 plus m2. And we can apply that along the x-axis. So how do we do this? Guys, we can just take the component of this v dash cos 45 times m plus this guy v dash cos 45 again with m plus vr cos 45 again with an m, and we divide that with 2m. Okay, all right. So if you solve for it, you see, putting the value of v dash and vr, what will we get? First of all, we can cancel this m. Cancel all of the m. Cos 45 can be taken out to be common. 1 upon root 2 can be taken out to be common. We have v dash, actually 2v dash plus vr upon 2. That's what we have found from here. Do we have the value of v dash and vr? Yes, we have v dash and vr. Where is v dash? So vr is 4 root 2 upon 7. Okay. And v dash is 2 root 2 upon 7. Correct? V dash is 2 root 2 upon 7 v naught, and vr is, in fact, vr is 2 v dash. Okay. So 2 v dash is just simply vr. So 1 upon 2 root 2. So this is actually 2 vr, because 2 v dash is vr, no? We found out over here. Where is that? 2 v dash is vr. Okay. Now 2 cancels. So this is basically vr upon root 2. And what was vr? Vr was 4 root 2 by 7 v naught. So this is 1 by root 2, 4 root 2 by 7 v naught, and that gives us 4 by 7 v naught. Okay, very simple. So that solves it. Okay, you see that in this approach, we did not have to use a lot of quadratic equations and the energy equation. Without using the energy equation, with simply using the Newton's law of restitution, we have been able to come to the final answer. Now, one very important thing which I want your focus on is that, guys, that whenever it is given in the questions that the collision is perfectly elastic, some students make this mistake that they apply the equation of restitution, Newton's law of restitution. They put E equals to 1, but they also tend to apply conservation of energy. Okay. What I'm trying to tell you is that the equations that you will get out of applying conservation of energy and putting E equals to 1 in Newton's law of restitution, you will get the same correlation. You will not get a new equation out of that. Okay, so please take care of this in mind, and I hope you enjoyed this solution. Guys, I will see you next time with more amazing problems. Until then, stay physics rich.